Hello, my name is Patrick Fleming, and I will be presenting today constant velocity and Newton's second law for this lab report. What we're going to start with is how we get from force equals mass times acceleration, which is Newton's fundamental second law, to the formula we will be using for this class, which is velocity final equals velocity initial plus the net force over the mass times the change in time. By doing some simple mathematics, we can calculate the formula that we need for this lab. I am showing the work here in Paint. This is the final form that we will use for this lab. This is Newton's fundamental second law, but just in a different form. The program we use to track our velocity of the foam roller in this lab is Tracker. It is a great tool for graphing the velocity and tracking the velocity of our object. As you can see, we're tracking the velocity and plotting the data points on the right on a graph. We now apply Newton's second law by computing a model of the velocity of the foam roller into a Python application called VIDLE. By using VIDLE, we can model the behavior of the foam roller with no air resistance or friction and see what a predicted motion would look like for this foam roller. This is very similar to the motion we've seen in the tracker program, but as we plot the graphs together in an Excel spreadsheet, we will see the differences. As you can tell, in the beginning, there are very little difference between the predicted values modeled by our computer application and our actual values. But as time gets larger, the actual values start to decrease from the predicted values. We can explain this through a little air explanation. Our predicted values say velocity final equals velocity initial plus F net over mass delta t. For predicting our values, we say F net over mass delta t equals 0, that the net force will not change throughout our experiment. By saying that the net force will not change, we will get this linear line. But, as we could tell from our Excel graph, that was not the case. The reason, because our actual values, the net force is going to be negative. With a negative net force, the final velocity is going to be getting slower throughout time. What this would look like is eventually the velocity would get to 0 as our net force slows down our object completely due to friction and air resistance. What this means, based on our assumptions, is that not particularly that Newton's second law is incorrect, but our assumptions made our predicted values incorrect. We can now conclude our project by stating how the assumptions of negligent air resistance and friction can throw off a lab report and slow down an object. We can better provide answers next time by predicting friction or measuring the coefficient of friction for a given object. The use of technology also greatly enhanced this project by letting us graph the constant velocity predicted and constant velocity actual values.